Good evening. My name is Oliver Strijbis. I'm assistant professor for political science at the University of Zurich. And this is my second attempt with this presentation. First attempt, I didn't look on the clock and I talked for half an hour. So I try to be brief, share with you my slideshow, and let's go. The title of my presentation is The Sequencing Method, Analyzing Election Campaigns with Prediction Markets. So I'm going to talk about prediction markets and how I use this method to analyze election campaigns. What I'm interested is in something very basic for political science, since it's an issue since the standard work of Lazarsfeld and others, and this is whether campaigns are mostly activating and converting voters. Do they actually make voters aware of their predispositions and make them vote according to them? Or do they convince voters to vote for a candidate, a party, or a yes or no in a direct democratic vote during the campaign, and maybe also make people change their mind during a campaign? This is crucial to understand election and direct democratic campaigns, and I think very often we still don't know this for elections, even for US presidential elections. This is often still a debate, how much activation and conversion is going on there. And it's certainly unknown for direct democratic campaigns, which will be my field of application. Right. So I use prediction market. What is a prediction market? It's a financial market run with the purpose of using the information of the market values, so prices, to make predictions. So since Hayek, we know that prices on markets, they contain important information about the value of assets. Right, according to Graefe, prediction markets produce excellent forecasts for elections, and there are previous applications of prediction markets to elections and direct democratic votes that showed its potential to analyze campaign effects. However, so far it's always used to look, or what they forecasted were point estimates for vote shares, or the likelihood that a yes or no would take place. But we never had a forecast for the vote share that different parties or candidates would achieve, plus the uncertainty about this. Now, with what I call the sequencing method, I will exactly try to do this. I will forecast, or I am forecasting, probabilities about vote ranges or sequences of votes. I'm doing this by, we have here an example for a current US presidential election. I have 4 markets going on at the time: US presidential elections, regional elections in Spain, direct democratic votes in Switzerland, and forecasts on migration flows. I give always ranges of vote shares, and what traders are betting on is the likelihood that these vote shares will be the ones that are actually will take place, will happen. So currently, the probability that the Democratic candidate will receive between 45 and 50% of the votes is a bit above 30%. The final value of each share, which you can buy now for 32 virtual US dollars, is 100 virtual dollars if this is actually the event that happens, and it's 0 if it does not happen. So if you buy now, you win for each share $68 if this is actually what happens, or you lose 32 if it does not. And you can sell, and the logic applies, just vice versa. Right, I like to compare this with poll of polls, which is the traditional, or now the most used method to look at campaign effects or these general campaign effects. And poll of polls are actually very good to look at conversion effects, or very good, they're good enough, I would say, because you can really argue that a lasting change in the signal, in the vote intention, reveals that there was some conversion going on. However, it's very difficult to measure activation effects, because the reduction of the uncertainty in polls of polls is influenced by many things, many of them methodological things, size of samples, herding towards the end of the campaign, house effects, what do I know? And it's very difficult to isolate the uncertainty that is due to uncertainty in the vote intentions of the voters, which is actually what measures activation effects. So this is why I think that prediction markets have a big potential, at least if we use it the way I propose with these sequences, because this allows us to look at conversion effects, which we would say happen when the forecasts change, and they change towards what is finally the result. So this means nothing else that the prediction error for the precise vote share, that this is reduced. This would be a conversion effect or evidence for a conversion effect. While a measure indicator for activation effect is the reduction in the uncertainty of the prediction. Right? So when the prediction error is reduced and we are more certain about the outcome, we have seen both a conversion and an activation effect. There are some potential issues with this. One is, so how do we come from these ranges to actually point estimates of the outcome? And the other would be that basically polls also reveal information about predispositions of the voters, and so we should take this into account, because this is not exactly what we want to measure. So in the Q&A, if there is one, I'm happy to reply on this, but I fear there is no time for that. You must believe that I somehow accounted for this problem or potential problem. Let's quickly look at the application of this method. So I give traders on the prediction market 50 Swiss francs, about 45 euros. I have at least 100 participants. Now it's usually more, between 150 and 300. These are typically political science students. And I have to set starting prices, which I do with a very basic forecasting model. Now, I did this for 70 national votes since 2017. For all of them, I have uninterrupted time series data. I censored this data to the last 60 days, which is about when direct democratic campaigns in Switzerland start. They are pretty short term, and everything was published live, so ex ante forecasts on a web page. Let's jump to the results. What you can see here is that the forecasting error in terms of yes vote shares on direct democratic ballots is reduced over these 60 days by around 3.5%. So this means this is basically our estimate for the average campaign effect in terms of conversion of the voters in Swiss direct democratic campaigns. So it's not that much, right? It's like the campaign can only decide a vote if a vote is pretty narrow, between 46.5 and 53.5% on average. We see a higher reduction in the uncertainty. So the average 90% confidence interval of the yes vote shares in percent, the average reduction is 6%. So this is a somewhat stronger activation effect than conversion effect, which means that most voters, they are only activated during the campaign. They get aware of their predisposition. Most important in Switzerland is usually their party identification. Once they get to know the position of the parties on direct democratic ballots, they make up their mind because they know what their party identification is. So it's not so surprising that this effect is somewhat stronger than the conversion effect. Let's finish with a short conclusion. So I think this is for the first time that we can really show the average size of campaign effects in direct democracy, that we have a good measure for that. And we see we have non-trivial conversion effects, but we have stronger activation effects. At least this is true for Switzerland. Now, what would be interesting to look at in the future is for which proposals there are stronger conversion effects and for which one we basically only have activation effects, and why this is so. This would give us a lot of clue about what is actually happening in direct democratic campaigns in Switzerland. And of course, I want to apply this method also for elections. I collected now this data for a number of elections, and I'm going to investigate the conversion and activation effects in these elections. Looking forward to see your presentations in this conference, and have a good time.